ladies and gentlemen, that was my rather crude attempt at having a title page and a theme song for Humdinger Nation. So before you open your binders, I'd like you to just watch this and listen to some of the vocabulary that I need to talk about. We are on 6.2a lesson, comparing the perimeter and area of polygons. And remember, I only have 15 minutes, so sometimes I'll need to talk fast. All right, the first activity shows an image of a rectangle, and I'm going to name that rectangle MNOP, not R, excuse me. And you can see that this rectangle measures 3 units by 6 units. On the first grid provided, which I've labeled number 1, you're going to draw a rectangle with sides 3 times as long as the image, and you're going to label the corresponding vertices Q, R, S, and T. On the second grid, draw a rectangle with side lengths 1/3 as long as this image, and label those corresponding vertices U, V, W, and X. And corresponding has a very specific meaning in this context. We've got rectangle MNOP. The corresponding vertex to M is vertex Q when we draw the larger image. N corresponds to R, so these are all going to be in a very specific location in space, and you can see S and T as well. So your first task is going to be drawing those figures. Then you're going to fill out the table at the bottom of the page, and you can see rectangle MNOP, which is our given, is already done for you. Change in dimensions, I'm just going to cross that out. That makes no sense because the change in perimeter, change in area, change in dimensions, this is our initial starting point. So you're going to complete this table, I'm guessing 7 minutes. I'm going to ask the sub to pause the video and give you all about 7 minutes to complete this page. Then turn the video back on when you're done. Pause the video, please. Okay, welcome back. You can see that this task was really pretty simple, but I do want you to focus on the vertices. Do you have them corresponding parts? In other words, is Q, R, S, and T in the same place as mine is, and the same with regard to U, V, W, and X. That's corresponding, which we'll talk about more later. When we go down to the table, the big takeaway here is that when the dimensions triple in the largest rectangle, you can see that the perimeter also triples, but the area changes by a factor of 9. And that makes sense because area is squared, and when we triple our dimensions by multiplying them by 3 times 3 is 9. With the smaller rectangle, we took 1/3 of the dimensions, and the perimeter was also 1/3 of the original, and 1/9 of the original in area, and that's because 1/3 squared is 1/3 times 1/3, which is 1/9. Because area squares the dimensions, it will change by a factor that is squared. Okay, do not turn the page, just watch me on this next one. I want to make sure that you pay attention to what I want you to pay attention to, so no turning the page. We are on the next page. It says define a variable, write an equation, solve, and state your answer in a full sentence. And this is not just for number 2, this is for numbers 2, 4, and 6. So we have a rectangle with a perimeter of 148.6 meters. Notice I'm annotating the problem. And a width of 29.2 meters. Find the area of the rectangle. So if you're paying attention here, you'll notice that we have the width, but we do not have the length. So this is a 2-step problem. Step 1 is finding the length. Once we have that, we can use it to find the area. So I'm going to write a let statement. Let x equal the length. And you're not writing, you're just watching, please. I want you to use formulas. Again, 2L plus 2W equals the perimeter, because we're given the perimeter. So when we substitute, we're going to substitute in an x in for the length, 29.2 for the width, equals 148.6. Now I will be skipping some steps in the interest of time, because I only have 15 minutes. 148.6. And then you'll have 2x equals 90.2, giving us x equals 45.1. And that will be meters. I'm not going to put any units in there until I do step 2. Finding the area. The area is length times width, 45.1 times 29.2, and my final answer, and I'm not going to write this in a sentence because I don't have room, 1316.92, and it's meters squared or square meters. And I'm just going to leave it at that. So that's what the method you're going to be using throughout this page. Let me remind you that the formula for the area of a square, so notice square here, number 4, the area is side squared, s squared, and the perimeter formula is 4s. And I'm going to require you to use formulas here, so please don't resist that. All right, we're almost 6 minutes in. We are 6 minutes in. I'm going to ask the sub to pause the video, please, and complete this page. I'm guessing 10 minutes, and I'd like some good conversations on number 3 and number 4, please. Okay, pause the video. Okay, welcome back. I hope you found this page interesting and maybe even the last one challenging because of the units. Number 3, the big idea is if the dimensions increase by a factor of 3, the area will be 9 times bigger. So you should have gotten the new area would be 11,852.28 meters squared. Number 4, 225 meters squared or 225 square meters. Please note in the bubble here, I do not want you writing 225 square meters. That is not squaring the meters, it's squaring the 225. So that would be wrong. Number 5, if the area was 1/4 the size as the problem above, the length of each side would be half as long. Remember, area is squared, and 1/2 squared equals 4. I'm looking right here. Number 6 was a 3-step problem. The units must be the same when you work these problems. So 9 inches, my first step was to convert 9 inches to 0.75 feet. Step 1, find the area of one tile. Step 2, find the area of the floor. And step 3, divide the area of the floor by the area of one tile, and you will need 448 tiles. I'm going to leave this problem up in case anybody needs to do corrections. I'm going to pause the video. When you come back, we'll be turning the page, but I need to talk to you about how to do this first. So please do not turn the page. I'll give you some handy-dandy tips, and you know they're worth your time and money. All right, so let's pause the video now, please. See you in a couple of minutes. Okay, welcome back. Remember, you can always pause the video, rewind the video, play back the video, whatever you need to do. And I will be posting this on my website as well. So if any of this went too quickly for you, yeah, it's going to be there for you. Also, I hope things went well with the registration. I know Mrs. McNeff is coming in, and if you have any questions for me regarding your math class for next year, I have definite opinions. Some of you probably will be overly challenged with Math B honors. So if you have any questions about your own self, please ask. Happy to help. Okay, activity 2. I'm now on page, I don't know what page this is in your stuff. But we're working with triangles now. Below is an image of triangle ABC. On the first grid, draw a triangle with side lengths twice as long as this image. Label the corresponding vertices D, E, F. And on the other grid, draw a triangle with side lengths half as long as this image. Label the corresponding vertices G, H, I. Please note in this triangle, and I don't know why mine is doing this, I can't get it to go away, but in this one, ABC is in counterclockwise order, so pay attention when you're doing your corresponding vertices. And my big hint is the same hint I've been giving you for all of last week. Always draw the horizontal line first. Be sure that the labels correspond. All right, so would you please do this page and this page only. When we turn the page, we're going to be talking about similar triangles, and that's special vocabulary and special instruction from me. So please pause the video and finish this page with your groups. Be sure to talk. Thank you. Pause the video. Okay, here we go. Hope this was easy for you. I think that probably the most difficult thing was to find where that vertex was. I labeled the base and the height of the given triangle. You cannot measure with square units side AC or side BC. So the way that I did it was I started at vertex A, and to get to vertex C, I counted up 4 units over 2 units. And so all I needed to do for the larger triangle was to double that, up 8 over 4, and on the smaller triangle, I'm going up 2 and over 1. Make sure that your corresponding vertices do actually correspond. I just told you the method that I used to double the length of each side. And at number 8, those angles will be congruent because the triangle is being scaled up or down but not changing their shapes. This is very similar to the AAA triangles, the angle triangles that you had last week, where you could make as many as you wanted to, big, small, large, in between, didn't really matter. Those angles were preserved. All right, so pause the video if you need to. You can go and copy this information or talk about this information if you found it difficult. We're on the next to the last page, the penultimate page next, some new vocabulary and some new ideas. So pause the video. I'll see you back for the next page. Okay, welcome back. I have less than 4 minutes to go on the video. So we're now on the next page, and it says to list the corresponding angles and sides in the two triangles. You really need to study these in order to see the similarities. Actually, it's pretty obvious those angles all match. The angles are all the same. The side lengths are different. So we're talking about scaling up, scaling down, triangles exactly as we were before. Corresponding angles. So corresponding angles have the same measure. So when we list the corresponding angles, we should have a list of 3 things. So we could start with angle R, and you can see that angle R corresponds to angle C. Angle R and angle C are one of the corresponding angle pairs. You'll have 2 more. And then let's talk about the sides. So when I go from R to Q, that's this side here, I'm going from 117 to 48 degrees. That corresponds to this side, CB. So I would also have side RQ and side CB. It would be wrong, and here's something that you probably hadn't thought about, it would be wrong to say side BC corresponds to RQ, because that would tell me that angle B has the same measure as angle R, and it does not. So would you please list, and let me number these for you so you know what I'm talking about. You should have 3 angle pairs and 3 side pairs. And then complete this page, pause the video. Should take probably, I don't know, 5-6 minutes. Give it a go. Please pause the video. Okay, with 2 minutes to go, I can't talk as much as I'd like, but feel free to pause the video wherever and how often, I don't care. I want you to pay attention to this note. In triangles, you do not need to use 3 letters to name a vertex, but of course you can. Not a problem. This idea of similarity and the idea of scaling, which is what we talk about in number 11, scaling up and scaling down. Scaling just means to enlarge or to reduce, which is what section 6.2 is about, so that's kind of a heads up for the future. Pause this as much as you need to. I think I showed you the pages sufficiently. Go back if you need to. And then on the last page are some definitions. And remember, definitions are really important, so I'm going to just ask you to, I'm going to talk about a few things, and then I'm going to let you pause the video. In the first one, similar figures, they have the same shape, but not necessarily the same size. The angles are congruent, and the side lengths are proportional. The symbol, this little squiggle, means is similar to, and you can see in the last column in the example, we're showing using arc marks to show congruency, and I'm making the statement at the bottom that triangle ABC is similar to triangle FEG, meaning they have congruent angles and the corresponding parts are proportional. Sides, excuse me, are proportional. Corresponding parts we've talked about. And just make a note that the naming order does matter. So I'm out of time. You're probably out of patience. I'm going to ask the sub to pause the video so you can copy down these definitions. And any time that is left, please use wisely on your homework. All right, please pause the video. Have a great day and say thank you to the sub, please. Okay, bye-bye.